And welcome, everybody, to another episode of In Stereo with Mike and Rick. I'm Mike Bovaird.
And I'm Rick Miller.
And we are talking all things audio today. Today's special guest is Caelin Gabriel from Shunyata. Caelin, welcome.
Hi, Mike.
How are you?
I'm very happy to be here.
Thank you so much for making the journey to be with us actually in the studio. We greatly appreciate it.
I'm happy you survived the hurricane.
We did.
And the various viruses that are running around.
Yes, we did.
It's good to be with human beings and not on Zoom.
Absolutely. Some of us have survived the COVID virus better than others.
Yeah.
Mike Malley. Anyway, thank you very much for coming today. So there's been a lot of talk about the new grounding system that you've come out with. Mm-hmm. And we had the pleasure of using this or introducing it at the Florida Audio Expo in February. And one of the really cool things that we were able to do, or Richard was doing from your company, he was showing people with the ALTAIRA system in the system and when it was removed. And everybody that came to the room was just blown away by the improvement of the ALTAIRA system. Why don't you talk a little bit about, why you came up with this idea and how it's different from other products that are on the market?
Okay. Well, how did I come up with it? Well, I didn't come up with it.
Okay.
Grounding in audio and specifically in the telecommunications industry has been around since electronics. Usually equipment was in metal racks, and all equipment had ground posts for safety reasons. Power in those days, you didn't have that third pin in the AC. There was a neutral and there was hot. And if the equipment malfunctioned and a wire touched the chassis, you could be electrocuted. If you touched one component in the rack and touched another component in the rack, and one of them was energized, and you touched the other one that was grounded, you could be electrocuted, and it'll go right through your heart. So it was for safety reasons. And as time has gone on with modern consumer electronics, much of that electronics now has plastic chassis, and people have forgotten about or don't practice grounding the equipment together. So there's many reasons why you would want to ground all the components in a system together. The primary one, which people don't really fundamentally understand, is just because I might have a DAC and I might have a preamp and I might have an amplifier, and even if they're all plugged into the same circuit, there can actually be voltage differences between the reference grounds of one component to the next. And that has to do with things like leakage current. If it's a big component like an amplifier and they've got big transformers, those transformers can actually induce a current in the chassis. And so if you measured the voltage on that chassis compared to an earth ground, you might find several millivolts to actually as tens of volts AC on that chassis. So especially if you're interconnecting components using RCAs, this is where you get ground loops, is when there's potential differences. And by potential, I mean as in voltage potential. There's a difference in voltage between one component and the other one. And when you connect the two RCAs together, you're actually connecting both chassis grounds together through the ground wire of the RCA, and currents run through that and modulate the signal. This is how you get hum. And even if you don't get hum, you can have ground currents that are high frequency in nature.
Mm-hmm.
So they might be radio frequencies, AM, FM, Wi-Fi, and even those, you don't experience those as a hum, you experience them as noise or a hashy sound.
In the upper frequency, usually?
Yeah, it rides the music itself. So you don't hear it separately as noise. So it's not like some people will say, well, my system is not noisy. I turn I don't play a signal, and I walk up to the speaker and I put my ear up to the speaker and I don't hear anything. Therefore, I don't have any noise. That's not true.
Right, right.
That's not true. The noise actually modulates the signal as it's amplified through the different stages of amplification, through the DAC, through the preamplifier, and through the amplifier. So this type of noise rides the signal. So if you look at it on an oscilloscope, Rick, you do this. If you play a pure sine wave, you can actually see the noise in the different frequency components. And then if you run it through a spectrum analyzer, you'll find out what those specific frequency components are. So I'm not saying that grounding will get rid of all of that. What I'm saying that is a big source of those types of noise can be moderated if you properly ground the system. You'll notice that so far, I haven't talked about anybody's grounding system. I'm talking about grounding.
Grounding in general.
Just simply having a common electrical point that you run a ground wire to every one of the components in your system. That alone will improve the performance of your system. So essentially, you don't have to spend anything, and you can get really big performance improvements by simply grounding the components. So in recording studios, quite often they'll use ground braid that's 2, 3, 4 inches wide, and they'll run it underneath the floor. They have raised floors, and then all the racks, they'll have ground braid that runs from each component down to that long ground braid, and that ground braid is connected to a giant bolt that is then connected to a rod in the earth.
Right.
So everything is connected to a common earth ground. So that is the reference point that everything else is connected to.
And a common earth ground would be something like the ground lug on the back of the Denali, for example.
Well, if you're in a home, let's just say you're an audiophile and you're in your home, earth ground starts from the grounding rod
in the ground
at your electrical panel.
Got it.
So by code, you have to have a grounding rod, and the power that comes into your service panel has 240 volts. It's got a positive. It's a split phase power system, so it's got 120 volts on one side, 120 volts, 180 degrees out of phase. When you combine them, you have 240. When they're split, you have one side of the panel is 120, and the other side of the panel is 120. And also, there's a ground cable that comes in, and that's connected to the grounding rod and to the grounds in the panel. So the grounding rod, as far as the home and the electrical panel is concerned, that is the reference point.
Okay.
And then all the ground wires in the electrical panel, you have a ground wire for each circuit that goes to an outlet in your home.
Okay.
Okay. So those are all considered an earth ground, but they're derived from that point at the panel. Now, you guys all know that any length of wire has resistance, inductance, and capacitance. So it's essentially a very simple filter. It really doesn't matter if they're pretty short lengths. But when you're talking about power lines in your walls, those can be 20, 50, 100, 200 feet long. And those do have significant resistance and inductance primarily. So if you could measure the voltage at an outlet in your home, let's say the circuit was 50 feet long, and then if you could actually at the other end test it at the ground rod, you would actually see that there's a voltage there. So most people, when they hear the word, whether it's in the context of electrical systems or if it's in the context of electronics, when people hear ground, they automatically assume zero. That means zero. No, it doesn't mean zero. There are many grounds in the system. There's the grounding rod, there's the grounds in the electrical panel, there are the chassis grounds, and there are signal grounds within the components. And each of those can have a relative potential difference between them. So the very first step to help neutralize or equalize all of those is to connect everything together to a common grounding point. Some people say star grounding. Okay. So that's the first step. That's the first step in grounding. Now, once you've done that, well, let me back up a minute. Let's say this. Let's say someone's, you've heard about a great grounding box, and you said, well, my friends love it. People on the forums are talking about it. I'm going to get that, and I'm going to hook that up. And you hook it up, and you run the ground wires to the components, and then you go, oh my God, that's incredible. I would say, are you comparing that to no grounding system, like the simple one I'm saying is just get some ground braid or a big bolt and connect all the grounds together? So are you comparing it to that or nothing? So I would say if you're going to buy something, you should first start with the simplest form of grounding, because that's now your baseline.
Okay.
And when you do that, you're going to have a performance increase. So if someone wants to sell you a grounding device like we have one, I encourage you to make sure you have a good star grounded system to start with. Otherwise, why should you spend hundreds to thousands of dollars on a component where you're not comparing it fairly? So someone can create a box, and in that box there's nothing but a wire, and all the terminals are connected to that wire. So essentially the box is doing nothing more than providing a common star grounded point to connect all the grounds.
Yes.
You don't need that to get there, right? So unless these devices do something above and beyond that, you're wasting your money. You're wasting your money. You're wasting your time.
And that's how your system is unique from what else is out there on the market. You're the only one that I'm aware of that has addressed both chassis grounding and signal grounding. So I'm going to turn this around so people can see. And unless I'm mistaken, this is the chassis ground, as you can see by the black terminals, and the signal ground is the white terminals. So can you talk a little bit about why you would do a chassis ground and a signal ground? And then I want Rick to talk a little bit about what's in here that makes it unique from just tying them together.
Okay, I'll do that, but I want to hold that for 1 minute because I don't want to miss a point.
Okay.
Which I think is an important point. You need to give credit to people that deserve credit. And we didn't create the concept of making a grounding box that does something over and above just connecting things together. I would give that credit primarily to Entrek or Entrek.
Okay.
It depends on how you want to pronounce it. I don't know the correct way to pronounce it. But they created an almost cult following and they they make these boxes. They're
Wooden boxes.
yeah, they're
Yeah.
wood,
Hmm.
so
Yeah.
it's an artisan product.
Hmm.
It's not our style.
Yeah. Hmm.
But I appreciate it,
Okay.
because they're purists. They're making things out of wood instead of metals, and they pay attention to ferrous materials. And so I really appreciate what they have done. And I would say that within the audiophile community, they created a niche, and they kind of popularized the idea. And then other people have come along since
Yeah.
and recognize that, yeah, this does make a difference, and have created products.
Right.
Now, I've resisted this for years because I was told more than 10 years ago,
Hmm.
you need to create a grounding box. And I said, well, why the hell should I create a grounding box when there's a whole bunch of grounding boxes already out there?
Right.
I don't like to make a product unless there's a need for it,
Hmm.
or there's a significant lack in what's out there's capabilities. So if I can create a product that can significantly advance the performance standard that exists,
Hmm.
then yes, I'll do it. I didn't see that with the grounding products. And quite frankly, I don't like the fact that the products that existed, people would put them in, and then they would have all these different wires, some of them thin, some of them copper, some of them silver. And people online would argue about, well, I tried this wire and then I tried this other one and it made a different sound. And so everything was very unscientific, very unrepeatable. And the comments from people was, well, you just have to try it. And it might work with one component, but it won't work with another component. Some components you can connect, some components you can't connect. And so that's just not our profile.
Hmm.
And that's not our customer. We want to produce things that have legitimate, logical, scientific reasons for why they work.
Hmm.
And so if I was going to create a product, we would have to thoroughly understand the principles behind it, and it would have to be repeatable in every system that it gets hooked up in. I don't want variable results. I don't want to put a product out there to customers and dealers where it's, oh, we'll just try it. And then, you got 16 different flavors of cables, and they all do something different. As far as flavors, performance, maybe not. So, all credit to Intrigue. And many people have followed on, and
But
I finally relented and said, okay, look, this was about 4 years ago.
Hmm.
I said, all right, I'm going to start researching it. And so I went back to all the fundamentals of grounding, starting back in the 20s, 30s, 40s, and my experience in the military, and then re-examined grounding systems as it relates in an audio system. Why would it work? Why wouldn't it work? And to more clearly define grounding. That was the first step. The first step wasn't create a product, create a box with a bunch of terminals so you could have a product too. That wasn't our goal. The goal was to understand grounding and create a system where people could install a grounding system where they would get consistently good results.
Okay. But one of the things that I've noticed is that I don't know of another group of products that are out there that does the chassis ground and the signal ground.
Right. Yeah.
So can you talk a little bit about why that was part of your unique approach?
Yeah, sure. So one of the things I discovered in the research that relates to what I just talked about the variable results, is that people didn't understand the difference between an earth and chassis ground and a signal ground. And many times they were connecting components to the chassis and other components to a signal ground. And sometimes they get great results and they go, oh my God, this is incredible. And then somebody else tried it with a different component and they said, you're out of your freaking mind. That sounds terrible. And so I'm a person that when someone says something, I tend to believe them.
Mm-hmm.
And so then I'm going, well, why is this person getting this result and this person getting the other result? And what I found is that it has to do with the fundamental differences between chassis grounds and signal grounds that people did not understand. And to launch a product like the ALTAIRA, we first had to re-educate or teach people about grounding first.
Mm-hmm.
And then once you understood those principles, then you could use these products appropriately, where there's actually two different versions. One's designed for chassis grounding, one's designed for signal grounding specifically. So I guess I'll talk a little bit about, I'm saying that there's a difference between a chassis ground and signal ground, and people are probably thinking, well, what is that?
Right.
What is that difference?
Right.
So fundamentally, when I talked about the earth ground at the electrical panel, that was put there for safety reasons. You have electrical strikes, which if it hits the panel or the wiring, that energy gets dissipated to the ground rod, and it keeps the energy from coming into the home and electrocuting people.
Mm-hmm.
The second reason was for the safety grounds in the electrical panel. So if something like a washer or a dryer, if a wire comes loose and touches the metal chassis, the ground wire, the safety wire, will conduct current. It's like a short, and it will blow the circuit breaker in the electrical panel. So that third pin on your outlets is there entirely to prevent electrocution.
Safety.
Yes, you need to keep from electrocuting people, which was very common before the National Electrical Code changed that. There's still old homes in Kentucky, Illinois, really old homes that still haven't upgraded their electrical system, but that's the primary reason for it. So that safety connection is what we call a chassis ground. So for instance, on this component.
So on this component,
right, this one has a dedicated ground terminal, which is great.
So does the Arrender as well.
Right. So if you look here, they have a dedicated ground post, and here's the electrical inlet.
Mm-hmm.
So this third pin on the electrical input,
The middle pin.
Yes. This is the ground pin.
Mm-hmm.
That's the ground pin. And so that connects in the power cable to the ground wire, which connects to the ground in the outlet, which is that ground wire that runs to your electrical panel that blows the breaker.
That's a safety ground.
That's safety ground.
Yeah.
And this is why I always insist, this is an audiophile thing. Cheater plugs. Well, I have a hum, so I'm going to use a cheater plug. You've just now completely disabled that safety ground. And it's not there. Some audiophiles mistakenly believe that ground is there to reduce noise. That's absolutely not true. The ground is there to keep from electrocuting your ass.
Yeah.
And when you disable that, you've now made it possible, if in the unlikely event, it is unlikely, but let's say this component, the chassis gets electrified, and you touch it, and you touch something else that is grounded, like a water faucet, another component that is properly grounded, that current will run through you, and you can potentially die. The big problem is when you touch something with one hand and another hand, it runs right across your chest and through your heart. So these are called defibrillators, but this one fibrillates you.
Right.
Yeah, ventricular fibrillation.
It stops your heart.
Yeah.
Not a good thing.
No.
You won't have a good day.
No.
Yeah.
Okay, so that's kind of a hot topic for me, is please don't do that. If you have hum, there are ways to get rid of the hum without using cheater plugs. That's not the topic of today.
Correct.
Maybe we could do one of those.
Yep, absolutely.
Okay.
Absolutely.
So internally, we do this in one of our videos, by the way, we take the top off these.
Yeah, I just want to stop you there. So everybody, you definitely want to be not using this video as sort of the de facto guide for the ins and outs of the grounding system. Shunyata has worked extensively at creating documentation, which you should read, and videos, which you should watch, around the grounding system. That is what is the real heart of the training system. We're here just to give a quick overview and talk about the differences of it, but I don't want this to be a substitute. So read the material, watch the videos. Okay?
Do your homework.
Do your homework.
Yeah, don't make a bunch of comments based on
Right.
this little excerpt, because this video, we're making this assuming you've already read all that
Correct.
stuff, especially the grounding concepts guide.
Correct.
Go read that before you fire off a snarky comment to me, Mike, or Rick, okay?
But snarky comments from Mike Malley are perfectly acceptable.
And welcome.
And welcome. Highly encouraged.
So
What did I ever do?
I think one fundamental thing people need to understand is this is required by NEC electrical code. This pin right here, there's a very short wire, and it does say in the code that the wire has to be as short as possible, and that wire runs directly from this ground pin to the closest place where you can make a physical connection to this metal chassis.
Yes.
That provides a conduction path between the chassis and the electrical ground to your panel. Okay, that's the only thing this does. And it is illegal, according to code, to put any type of switch or anything that would inhibit or interrupt or have the potential to disconnect that from current flow.
Now, if your product does not have, and again, watch the videos, read the material. If your product does not have a grounding post on the back of it, then there are other ways to chassis ground the component. You're going to have to read the material and watch the videos to understand. I don't want to get into a lot of details, but there are certain screws on the chassis in a certain location where you can test. Number one, you have to test it. You have to measure it to make sure, and then you can attach it there. But again, I don't want to get into a lot of those details. So sorry to interrupt. You continue.
Yeah, so let's go back to the topic, which was, well, difference between chassis and signal grounds. So everything that I've talked about so far is chassis grounds. So chassis grounds is exactly what it says it is. It is actually a ground connection to the chassis. So a grounding component, what you would do is let's say you have 4 components in your system, you would want to run a ground wire from each one of them to one of the individual posts on the ALTAIRA. And what this does is, first, it ties all the grounds together, and second, one of the unique things about the ALTAIRA is the ALTAIRA doesn't just connect the chassis together to a common point. It actually has proprietary filtering built in, so any noise that's riding on those grounds is reduced or eliminated. Furthermore, though each terminal has its own filtering, so each component is individually filtered while still maintaining a DC connection between all of the chassis.
That's impressive.
Yeah. And now let's talk about signal grounds. So a signal ground is something entirely different. Signal grounds don't start from the grounding rod. A signal ground actually starts within the power supply of each component. You notice I said each component. So every component has its own internal reference grounds for the electronics, the PCBs, the amplification circuits within that component. And that reference voltage, if we had an engineer and they were in here troubleshooting the component and they wanted to look at the signals, they're going to put one probe on the DC ground. that's the signal ground, and that's derived from the power supply. If a component has multiple independent power supplies, that component may have multiple separate signal grounds also. Okay? So one way to tap into the signal ground are the connectors on the back of the component. So for instance, on this component, you'll see the RCA connectors. You guys all know that the signal is the pin inside the RCA barrel. These that we see on the outside, these are all ground, signal ground. All right.
So
and then in an XLR,
Mhm.
it would be pin 1. In the XLR would be the signal ground.
So you're going to use an unused input or output, RCA, XLR, for example, to connect to the signal ground.
If appropriate, you really have to read the configuration
Yes,
guides
definitely.
about should I do chassis grounding, should I do signal grounding, and it really depends on the individual components.
Okay.
And that's why it's important to test each individual component, or look up on our website. We're building a library of which components is it best to use a chassis ground, is it best to use one of the signal grounds to ground it. Can you ground multiple connectors
Right.
on the component, or should
Right.
you just do one? So
Caelin, have you
yeah.
found that if somebody is going to start out with either chassis ground or signal ground, which one should they start with, in your opinion?
Always chassis ground.
Okay.
So since we have two different models of the grounding system, one design signal, one design chassis, some people just want to get their feet wet. They say, well, I want to experience what is, I've heard a lot about it. I just want to experience it. I don't want to spend a ton of money. I don't want to go crazy. I don't want a lot of complexity. Okay. And I always recommend that you start with a chassis hub.
Okay.
So get yourself an ALTAIRA chassis hub and connect as many of the chassis in your system as possible. Some of them you can easily connect. The ones that have dedicated terminals, it's really easy. Others, you may have to determine, can I get that ground through one of the RCAs or an XLR? And so just hook it up. Universally, the people that have done this, so for instance, when our director of sales, Grant, goes to dealers and does demos, people are astonished just plugging in the signal, a single hub, and just connecting 2-3 components in the system.
Yep.
Especially preamplifiers, by the way. I do recommend that you always start at the preamplifier. That's what everything else gets connected to, right? So I would start there. And then if you're happy with that result, and like the audiophiles that we are, we always want more performance. So live with that for a while. And then if you're thinking, well, is there greater levels of performance? There is. If you get into what we call segmentation and using domains to separate components into logical groups, and we call those a domain, very much like in the networking industry, where you have multiple Ethernet hubs that are separated into groups, and then they're interconnected. In the same way, we can do that with grounding and get better results.
So as an example, would somebody connect, for example, a render and their DAC and maybe something like a switch or something all together?
You can connect everything to this.
To get, but you were talking about the different
well,
zones and
okay,
whatnot.
so if we're going to get into the subject of how do I get higher levels of performance over and above just using one grounding hub? So now you're willing to invest more money, you're willing to invest more time, and you're willing to have a bit more complexity than simple system. So if you're willing to do that, the first place we recommend you start is segregating the digital components from the analog components.
Okay.
And most audiophiles instinctively already understand this, especially if you've come from the world of records, tape, and analog. Everyone understood back when, if you had a turntable system and then you bought a DAC, and that DAC was on, you go, wow, this sounds bad.
Right.
So you would turn that DAC, a CD player. You would turn that CD player off. That's just universally known, universal experience.
Because it's radiating noise.
Yeah, right.
Yeah.
So when you think about it, when you have a digital component, we know they have a lot of field gate arrays and multiple power supplies with multiple rectifiers all generating noise. They've got radio frequencies. They've got microchips in them. So by their very nature, digital components generate a lot more noise. And one common thing that engineers that design these components do is they dump that noise onto the ground wire, onto the grounds.
Yes.
And where does all that noise go? Well, we know you can't destroy energy. You can modify it, you can convert it, you can divert it somewhere. Well, I already told you, if they're diverting it to the grounds, ultimately it's going to go into the power supply ground, and then that power supply grounds are shared by all the other circuits in that component. So, and then it can be transmitted over the signal grounds that when you're connecting this component to a preamplifier or another component. So you actually have noise that's being transmitted through the grounds, not just different voltage levels. You're having noise that's being traveling through the interconnects from component to component.
So that one piece that's real noisy can contaminate other pieces that it's connected to through the interconnects.
Yeah.
Let me ask you a question. Right. Were there my understanding is, and please correct me if I'm wrong, is that somebody would either want to do on a component chassis ground or signal ground, but you'd never do both. Is that correct? Or is there an example where you do both?
Yes.
There is. Okay.
Yes. The reason I hesitate is because it's very component specific, and the components that you would exclusively do signal grounding with and not chassis grounding, those components are rare.
Okay.
That's because I left one fundamental thing out, which we will now go through. I said there's chassis grounds and there's signal grounds. So one way to characterize chassis grounds is that chassis grounds under normal operating conditions are not designed to carry current.
Okay.
So that ground wire in your wall, there should not be currents running through it.
No.
Okay.
No.
A signal ground that's derived from the power supply, it supplies voltages to the amplification circuits, and then on the other end of that are the grounds in the PCB and the ground wires that take that current back to the power supply. Signal grounds do carry current, and they carry signal current.
Yes.
So remember, in amplification, when you amplify something, it's the difference between the voltage and the ground. If you modulate the ground, if the ground moves up and down, it's going to modulate the signal. Okay? So that could be a low frequency one, which would be hum, and you experience it as hum. Or if it's a high frequency modulation, it impresses that noise on the signal and it rides the signal.
Okay.
You see the difference?
Yes. Yes.
And that would be between the center pin and the shield. That's where these signal currents circulate.
They start in the power supply.
Right.
So the place where they enter and exit a component is at the connectors. That's what connectors are for. Connectors are so I can connect this component to another component. But each component has its own power supplies, and that's where the signal grounds are generated. So you're connecting one set of signal grounds to a different set of signal grounds. And if the DC ground levels are different, you actually have a DC voltage running through the interconnects to the other component. You can have an AC component between the two components, and now you have modulated grounds between those two components. You see, so it's complex, and it gets more complex the more components you connect.
Right. So with this one, for the signal grounds, that was chassis ground, this was signal ground, you'd use something like this cable where you'd plug it into an unused RCA jack, and then the other end of this would go to one of these posts.
Well, let's not talk about how to hook it up, because that's covered really well in the user guide.
Okay.
Right.
I want to talk about the principle of what about these components where they don't have a dedicated ground terminal. There's not an easy way to connect the chassis to ground it. And the signal grounds are not related to the chassis ground. So now I have to be the engineer now and back it up a little bit. Caelin, you said chassis grounds are different than signal grounds. Yes, that's true. Chassis grounds are not designed to carry current, and they connect you to the wall, into the electrical system. Signal grounds are start in the power supply. They do carry current. They carry signal currents, okay? Internally, most components, especially most tube components, the signal ground of the power supply is directly connected to the chassis ground internally. So if you take an ohm meter and you measure the voltage from this IEC ground pin, which allows you to tap into the chassis ground, and you measured it to this RCA, in most cases, you'll find it reads 0 ohms, which means they're directly connected.
Yes.
And that's why and how in our documentation you'll see that if it doesn't have a dedicated ground post, you can chassis ground a component by using a spare RCA. So that's not a signal ground. That's a chassis ground.
Because they're connected together.
Because they're
internally.
connected.
Yeah.
All right, so I want to make sure you really understand that very clearly. That's really important to understand. Now, let's talk about a different class of components. Usually these components are quite exotic, quite expensive. I'll say constellation gear, all constellation gear, CH Precision, Solution. These have some very advanced engineers, and they go to great pains to make sure that their signal ground, they have multiple power supplies in their components, and they go through great pains to isolate them from noise. They also understand that isolating those grounds from chassis grounds, because they know there's noise on those earth grounds and chassis grounds, they want to be disconnected from it. So they either use opto-isolators, or they use transformer inputs and stuff, so that they're isolating their signal circuitry from chassis grounds. So in our user guides, we explain how to test the component externally. All you need is an ohm meter to determine, is that a component where the signal grounds are isolated from the chassis grounds?
Yes.
And if they are, you have to treat those components very different than common components. And this is one of the big reasons why the other grounding systems that people may have used, they get hugely variable results. Well, I tried it, it was okay, or I tried it, it hummed, I tried it, it didn't work, okay? This is because people did not recognize that they were connecting to a component that requires special treatment, but you don't even know about the special treatment if you don't recognize that there's a difference between chassis and signal grounds. You see why you have to understand the principles first. Once you understand the principles, then you can use something like an Altera that allows you to ground components like the constellation where the signal grounds are isolated from the chassis grounds, okay? And then other components in the system, you must use a separate grounding system or hub,
So in those
with those type of components.
when those type of components, would you use two of these, a signal ground and a chassis
Yeah,
ground?
yeah, right. So let's say I'm just using Constellation because I know it. I have
Yeah,
it.
it's great.
You
Yep.
know,
Yep.
we've done CH Precision and Robert Harley's system. We've
Mhm.
done Solution in Europe.
Mm-hmm.
All great. This is the general rule that I give people. Let's say you have a reasonably priced system. You know, you don't want to get into a lot of complexity, but you do recognize that grounding's important.
Mm-hmm.
And so I'll recommend to that person, well, get one hub, get the chassis version, and connect as many components as you can, and you're going to get a really big performance boost. You're good to go.
Mm-hmm.
Mm-hmm.
Then there's another category of person. Those are the ones that say, I don't care what the cost is, I don't care what the complexity is, I want the best.
Yeah.
Right? And for those people, I would say, well, don't start with the chassis hub. We're going to design your system custom, and it's going to be segmented. So we're going to, at minimum, segregate your analog, and we're going to put it on one hub. And we're going to separate your digital, and we're going to put it on a different hub. In those cases, I would always recommend that they get two of the signal hubs
Mm-hmm.
because they do a better job of separating those two domains.
That makes sense.
Yeah.
Yeah.
That's good.
That's good.
Rick, did you have any specific questions?
Well, I'd like Caelin to talk a little bit about, he touched on it earlier about, you could just run all, make your own system and run all these wires to a bolt.
Yeah.
But in your product, you have something very special. You have filtering in there that absorbs and reduces the noise. And I feel that's really a standout thing that everybody should know about, that this isn't just, there's not just a copper wire that connects all these things together in here. You've got some real scientific engineering, and I wish you'd talk about that a little bit.
I guess to talk about that is you have to talk about other grounding systems or other grounding hubs. And look, I'm not an expert on everybody's grounding box in the world. Some people will say, well, how does your technology compare to these guys? And I would have to say, well, I don't know for sure. I haven't bought them all, and I haven't ripped them all apart because, quite frankly, I'm not saying this to be a smartass, but I don't have to take them apart because I know what works and I know what doesn't work.
Yeah,
Okay.
for all your years of doing
But
this.
from what I know, from what I've heard, and by inference, many of these have things like ferrous materials, like iron filings and nickel filings, and basically powdered ferrite. Some of them have certain types of sand, and some of them have amethysts and different crystalline materials. So there's as many ways to attack this as there is the imagination of the people that designed it. As far as I know, we're the only people that are isolating each connection individually and filtering it at high frequencies. That's important to understand.
Yes.
Okay. So what we're doing is we're extracting the noise that's coming from that component, and then a different zone is extracting noise from another component that's connected. So we're reducing noise on one component and another component and another component. And then on the actual signal connections where those components are connected together, they're transmitting less noise across the signal wires. You understand how that's cumulative?
Yeah, so each terminal here goes through a filter, and then they're connected together.
Right, correct. Yeah.
So they're connected after they're filtered.
Yeah, they have a bus internally, and then you'll notice there's a seventh terminal. We call this the seventh terminal or the bus terminal. So if you have multiple Altairas, you want to interconnect all of them I'll go back to the network analogy. If you have multiple Ethernet hubs, you want them all connected to a central hub or to a router, right? So all grounding systems should be connected to an earth ground even the signal hub, you'll notice it has a earth ground connection. So let's say you have one of our Everest power conditioners. That's the perfect place to connect this, is to one of the grounding terminals on the Everest, or if you have a different brand of power conditioner, assuming it has a grounding terminal. And if it doesn't have a grounding terminal,
there's a problem.
That's not a great idea.
That's not good. Yeah.
That's not good.
No.
Okay.
Yeah. One of the questions I had for you is, when the Altera system is $29.95 for the box, and as I was mentioning earlier, we are going to be having a special on these. There'll be $3,000 if you purchase today. After
Wow.
Caelin's, yeah, exactly.
What a deal.
Anyway, joke aside, what I'm wondering about is, you have different grades of grounding cables, different levels.
Yeah.
Can you explain why there's, a Venom, a Delta, an Alpha, and what people would expect to hear differently?
Yeah. Okay. So just like we have different levels of power cables, starting from Venom, Delta, Alpha, Sigma, Omega.
Yeah.
What we've found is that the grounding systems react in a very similar way to power cables. So most people that have done the tests with different power cables find that as you get a better power cable, you get better performance to that component.
Right.
So the same principles, interestingly, apply to grounding.
Interesting.
Yeah.
That's very interesting.
So what I recommend people do is I recommend doing the simplest system. Get a chassis hub, get some Venom cables, hook it up, see what you think, play with it for a while. And we actually make demo kit cables for dealers where they can loan you a kit. So you don't have to go out and, go to the expense of buying this and then either being disappointed or and then feel like you got stuck with something. So most of our dealers have these kits where you can demo it in your own system. And remember that these are on loan to you. That's the dealer's demo kits. And they're clearly labeled, by the way.
That's a great idea, because then you don't feel you're getting stuck if you buy the wrong thing.
Yeah. And then...
These are our demo kits. So they have different connections. I'll just show everybody here real quickly.
Yeah.
You cannot buy these. These are just for the dealer demos. But essentially we have, we just got these actually. So we've got this, you've got this end here. It's kind of hard to see in the plastic, but you've got this end here, and it kind of looks like a super long RCA, but you connect that into one of these connections. So if the customer has an RCA connection that we're going to be using, we can just loan them this end and they can connect it, and they're off to the races. So we have different connections in here: USB, Ethernet, XLR. We've got all the different connections.
That's great.
So we can put that together, and then these are more generic cables that people can just connect the different ends on. But anyway.
Yeah, we just call those the base cables, and they're kind of universal. So if you have a component like an R-Render, you don't need these adapters. You just use the base cable.
Yeah.
And you plug the banana into the Altera, and then you connect the spade to the dedicated terminal on your component, and you're good to go.
Yeah.
But if you need to connect to one of the connectors to get a chassis ground or a signal ground, depending on the component, instead of having, I think we worked it out with the different number of cables we have and the different number of connectors, the dealer would need something like 218 different SKUs to have the different cables.
Mike, we need another warehouse for that.
The different cables in inventory.
Yeah.
I mean, how other manufacturers are doing it, I have no idea, but we said this is untenable, so we made this interchangeable system so that you don't have to run into those issues. And for the customer, let's say you start off with maybe a Venom level cable, and you need an adapter to get to an RCA, you can upgrade in the future to a Delta or an Alpha cable, and you don't have to buy that
Right.
adapter,
Right.
and vice versa.
Right.
So it's and if you get a different component and you're not using an RCA, let's say you're using an XLR or an Ethernet connector, you don't have to replace the whole cable, or worse, send the cable in to have it re-terminated.
Now, are you talking about the consumer or just the dealer for that purposes?
I'm talking about both, but
Okay.
primarily the customer,
Uh-huh.
because if you get a new component or a new rack, it may be farther away, or you're using a different connector, and now that cable you have is useless,
Yeah.
or you have to re-terminate it. So this interchangeable system makes it much simpler for both the dealer and the customer.
That's a great idea.
Yeah, that's
It
very,
is.
very good. Yeah. So you're saying, to really get an idea, the dealer would send them the chassis ground, the proper connections, and they can really hear the improvement it makes. I mean, for us, we've had an opportunity. We've been using these cables, so we've had an opportunity to use it in the store, and we hear just amazing black backgrounds. We hear way more space around the instruments.
100%.
I mean, Mike, you live in that Shunyata room.
I
so
do.
What are you hearing?
I'm loving it. It's incredible.
Yeah.
It's like you said, the background it goes completely black, and the soundstage,
It just appears out of.
it's incredible, and you get better depth,
Yeah.
all from this one little unit.
Three-dimensionality.
It's mind blowing.
You were there when Richard was doing the demos at the Florida Audio
Yeah,
Expo.
that was
was.
Mike's room.
That
in
was my
February.
room.
Yeah.
Yeah.
So you got to hear all the demos on and off, and
I did.
yeah, I know
It's mind
people
blowing.
came out of there going, "Okay, I want to buy it." And we're like, "Well, it's not actually ready yet." So
Yeah.
they've been very patient waiting for it.
And it took us a long time to get to
Well-
and I'll tell you why. It wasn't because we didn't have the units. It's because I wasn't well, and I was the one creating the information, and there's a prodigious amount of documentation, as you guys know. But you need that information, and so it took me quite some time to finish the concepts and come up with the user guides and the worksheets. So that's what we were waiting for, is completing the documentation and all the little guides to help you properly install this and configure it so that when you do install it, you get good results and you don't get those variable weird results.
So one of the interesting things that you've mentioned is the database that you're continuing to build and accumulate new information on different components. How far? I mean, how far along are you on the database?
Well, it's on the website, and we're adding to it daily, weekly.
Okay.
As we said, Grant is traveling Europe right now. He's in Germany. He's going to 3 different reviewers. We already have one review, which I can't tell you what it is, but it'll be out in just a few months.
Great. Looking forward to it.
And make sure you have them in inventory before that hits.
Okay.
That's all I can say. Because I will say this, when we release things now, we don't release the products unless I allow my production manager, Chris, to build a significant amount of inventory. Because when we release a product, we have a lot of distributors across the world and dealers where they might get one. Some dealers may have heard it and they'll commit to 2, 5, 10. So we need a significant number of units in the very beginning. So we built over 100 units of these. And how long have they been out? A couple months?
Yeah, a couple of months. Yeah.
So we've run through all of those.
Yeah. Wow.
And so Chris is now saying we're now building
more
to order because
Mm.
we ran completely through them. And that's before there's been any major reviews or a lot of people talking on the forums about them. This is just based on word of mouth, one person telling another person.
Mm-hmm.
So the wave is coming. It's a big wave. I'm surprised. I'm quite frankly surprised. Like I said, I really didn't want to build a ground system. The only reason I did is because eventually I determined, well, we can make something that is Shunyata and is unique and makes a consistent result. So
And
know.
speaking about consistency, I've seen in your literature on your website that the filtering in here, you have two types of filtering. You have
Yeah.
the NIC filtering and the CCI filtering. And you use that same filtering in your power products.
Yeah, it's
So
similar.
that's the
Similar.
consistency that
Yeah.
you're getting. And the
Right.
build quality is so good. I mean, look at this,
Yeah.
Yeah.
these products. The build quality
They're
is great.
heavy.
You have
Mhm.
filtering on each one, so it's not like the noise is going to come in one and go out the other one. It's going to be filtered by each one, and it's the same. If you like the sound and the effect you've gotten of Shunyata with their power products, then you can just imagine that same filtering is built into this. So you're really getting like a double dose of the
Yeah.
Shunyata goodness here.
Yeah, I agree.
Yeah.
Totally agree.
I think there's something that Grant and Richard have found in all the dealers and media people that have systems installed. There's several now, is that we're getting universally great results. Second, they're getting universally great results not with a maxed out system, with a simple system, with the alpha system, which is right in the middle for
Right.
the cabling.
That's
There's,
actually what we've been using is the alpha, the grounding, the alpha grounding system cables. That's what we've been using in the
Yeah.
store,
Yeah.
and we've been delighted. Everything we've connected it to, and we have so many different products that we bring in and out of there. Everything we connected to has had the same benefit, you know, and we've had no issues. I mean, we don't sell any goofy products that would have issues anyway. No oscillating products.
That's true.
Nothing like that, but,
Nothing too crazy.
but no, everything we've connected to, all the digital, the analog, all of the integrated amplifiers that we've had back there. We even brought over the Boulder 1161, the little baby Boulder amp. I can say that, and everyone thinks it's big, but it's not that big compared to the 2160. But anyway, and the preamp and everything we've connected the Altera to has just been fantastic.
It
Really
has been.
really good results. But yeah, we're excited. We're excited to get more of these into customers' homes. We just did a big system last week for a gentleman, and Richard and Grant were very helpful to make sure that we dotted the I's and crossed the T's and got everything appropriate for his somewhat complex system. Yeah, that's all done. So we encourage people to, watch the videos. Most importantly, read the material, and then, we can talk about how to implement it into your system. Yeah. Rick, any additional questions?
No, I think we pretty much covered everything.
Yeah, we really appreciate your time today. We know you're busy, and we know you got a lot of things to do, but we really appreciate you coming in here today and talking about this. This is an exciting new product for Shunyata, and we're interested and really excited to get it out into the market and to our customers.
Well, look, I always love coming to see you guys. This is my second time here. I wish I could come more now that I'm in Florida. I can see you more. It is a drive.
True. That's true.
But I really enjoy coming here.
We like having you here too.
Yeah, I feel you guys are one of the great dealers. I love what you're doing in the community, Mike, over and above.
Thank you.
Just, selling stuff and providing good service to customers. You are advancing the community, which I personally appreciate, and I know a lot of other people do also.
Well, I appreciate it. Thank you so much. Well, everybody, thanks for watching today. We've enjoyed having a great guest in the studio today, and thanks again for watching. And we'll be back with more In Stereo with Mike and Rick.